All right, last section in this equation review unit. This is section 3. The I can statement is I can solve multi-steps. So let's go ahead and write multi here. Multi-step equations. So these are going to have more than 2 steps for the most part. So let's take a look at the warm-up. It says, what do we do to each side before we start solving an equation? Well, remember we talked about this in the last section. So what we do is we simplify. So simplify. We simplify each side. Now, why do we do this? Well, generally, it makes it easier. So it makes it easier. It saves time. And this is the big one. Fewer, make that look right, fewer mistakes. We generally will make fewer mistakes if we simplify something, and that just kind of is common sense. Would you rather work with something that's complicated, or would you rather work with something that's simple? And that's what we do when we simplify things. We're going to simplify each side to write each side as simply as we possibly can. Now, what does it mean when a number is a solution to an equation? Hopefully everybody's got this one down. We talked about it in the last section. The solution makes the equation true. That is about the fanciest E I've ever drawn, so I'm going to have to get rid of that. So it makes the equation true. That's what it means to have a solution. Now, most of the simplifying that we've learned how to do so far involves 2 things. It involves distributing to get rid of parentheses. So if there are ever parentheses in a problem, you're going to want to distribute to get rid of those, and combining like terms. That's really what it comes down to when we're talking about simplifying. So once we've simplified each side, it's a really good idea that we always want to move the variable term to one side before we start moving the constants around. There are a lot of people that will say, oh, I want to move that -4, or I want to move that fraction or something like that. It's a really good idea to figure out which side you're going to get the variable on before you start figuring out where you're going to move other things, because it may end up that you have to undo some work that you've already done. So we always want to move the variable terms first. This makes the solving easier, usually saves us some time because then we don't have to do any backtrack. So if there's a variable term on both sides, we move the smaller one first. So the smallest one first. Now when we say the smallest one, what we mean is the one that's most negative, the one that's furthest left on the number line. And the reason we do this is it makes it so we have to work with fewer negatives. If you always move the smallest one, you're going to have fewer negatives. And everybody knows that we tend to make more mistakes with negatives than we do with positives. So let's keep that in mind. Again, we're going to simplify each side. We're going to isolate the variable term. So we're going to figure out where the variable goes first. And then we're going to get the variable by itself. So we're always going to show our work, and we're going to take a look at this, kind of glance through. That side is simplified. That side is simplified. So kind of step 1 is done for us. And then we're going to look at this. We've got a -3y here, and we've got a 5y here. We want to move the variable term first. We want to figure out whether we want to get the variables over on this side. So do we move the 5y over here, or do we get the y's on this side? Do we move the -3y over there? Now, don't even look at the 14 and the -10. They don't even matter at this point. What we want to do is we want to say, well, look, if I move the smallest one, and the smallest one of the 2 of these is the one that's most negative, that's going to be this one right here. So we're going to add 3y to this side, and we're going to add 3y to this side. So those are going to go ahead and cancel each other off. Now, at the same time, if you want to, you can move the 10 to the other side. I'm going to do this in 2 separate steps. So we're going to have 14 equals. This would be an 8y, and then I've got the -10 here. This now is a 2-step equation, so I need to move that -10. So I'm going to add 10 here. So this is 24 equals 8y. We're going to divide both sides by 8, and we get 3 equals y, and there's our answer. We'll go ahead and circle that. Okay, now this one is quite a bit more complicated. You'll notice that we've got some like terms that we need to combine over here, and we've got some distributing that we need to do. Normally distributing is a little bit more complicated. We want to make sure that we do that right, and then we're going to have some like terms to combine, but not always. Let's take a look at this. So we've got 2x plus 4 plus 5x. Now I'm going to, before I write this other side right here, here's what I'm going to do. I'm going to go ahead and identify those as like terms. So this is 7x plus 4. Then I'm going to write an equal sign, and then I'm going to identify those guys right there. Those are like terms. So I'm going to write down 9x, -9x, and then this would be a -14 over here. I've now simplified each side. I don't have any other like terms or parentheses to get rid of on either side, and now this is kind of a problem like I had over here. So I've got a 7x and I've got a -9x. Notice I'm not even talking about the 4 and the 14 yet. So this is the smallest one. It's the one that's furthest left on the number line. It's the one that's most negative. So I'm going to add 9x to both sides. So I'm going to put a 9x over here, and I'm just going to save myself some time just by crossing that off. Now, if I get the x's over here, I might as well move this on the other side right there. So here's what I'm going to do. I'm going to save myself a little bit of work by doing this. I'm going to subtract 4 on this side. So I move the 4 to the other side by subtracting 4. I move the 9x to the other side by adding 9x. So here's what we've got. We've got, let's see, gosh, this would make a 16x on this side. This would make a negative 18 on that side. And now I've got a one-step equation. All I need to do is divide by 16. Those are going to cancel each other off. Notice that 16 doesn't go in evenly, so I stop thinking of this as a division problem, start thinking of it as a fraction. And 2 goes into both of those. 2 is the biggest number that goes into both of those. So here's what we've got. 2 goes in here 8 times. 2 goes in here 9 times. Notice the negative, don't forget that. So we have negative 9/8, and that right there is the answer. So I'm going to slide down here, take a look at these other guys. So we've got some decimals on this one, so that's going to create a little bit of a problem here. Let's go ahead and get rid of that 2.1 here. So I'm going to multiply both sides by 2.1. Those are going to cancel. I've got a negative x minus a 9.5 here. I do have to grab a calculator for this one. In fact, we've got a couple we're going to use a calculator for. So I'm going to shrink this down, bring up that calculator, and let's see. So I've got negative 0.5 times 2.1. Hit enter. We've got negative 1.05. We would expect it to be about half the size of 2.1, and a negative times a positive is a negative, so kind of confirms what we would suspect here. So this is negative 1.05. We're going to go ahead and move this over to the other side by adding 9.5. Again, we've got the variable over there. So we have a negative x equals, and I've got the negative 1.05 plus 9.5. And again, here's how we can use our calculator to our advantage. Rather than type this whole thing in, let's just do this. Hit the plus sign, and notice that it says take that last answer, which is negative 1.05, and we're going to add 9.5 to it. So we end up with 8.45. 8.45. And then we don't want negative x, we want positive x. So we don't want 8.45, we want the opposite of that. So that's negative 8.45. And that right there, make that look nice, 8.45, that's the answer. Okay, let's take a look at this guy here. I'm going to zoom in on this so we can kind of tell what's going on here and potentially use the calculator also. So this has an asterisk by it, and you'll notice that we've got all these nasty fractions in here. And it says, since this is an equation, notice that we've got that equal sign in there. So because it's an equation, do we have to deal with fractions if we don't want to? And the answer to that is no. What we can do is we can clear the fractions. And remember, to clear fractions, what we need to do is we need to multiply by something that will cancel off all the denominators. We want to multiply by something that will cancel off a 6, a 3, a 6, and an 18. We want to multiply by the smallest number that will do that. Well, if you were to list out the multiples of 6, like 6 and 12 and 18 and 24 and so forth, and the multiples of 3, 3 and 6 and 9 and 12 and 15 and 18 and so forth, and the multiples of 18, which would be 18, 36, let's see, 54. You'll notice that I said 18 on every one of those. So here's what we're going to do. We're going to multiply both sides by 18. Now, if you don't want to do this and you want to do this the old school way, that's totally okay. So here's what's going to happen. We're going to multiply each one of these by 18. Well, notice that the 18 will cancel off the 6. The 18 would turn into a 3, so we'd have 3 times 7, so that's going to be 21y. The 18 would cancel off with the 3, that would be a 6, so this would be 6 times 11, so that's going to be 66. Same thing over on this side. The 18 is going to cancel with the 6 right here, so that's going to be a 3. So 3 times 5 would be 15. So this would be 15y. And the 18 is going to cancel with the 18, so we're left with just the 61 in the numerator there. So you'll, again, notice 4 fractions in the original problem. In one step, we've cleared the fractions and we've gotten rid of all of the denominators. There's not a single fraction in this problem anymore. Now we can go through and solve this, and we may end up with a fraction at the end, but we don't have to work with fractions in the meantime. So let's go ahead and do this. Again, ignoring the 66 and the 61, we look at the 21y and the 15y. 15 is the smallest, so I'm going to subtract 15y. Subtract 15y here, get rid of that. And that means I need to move this constant over on the other side. So I'm going to do that by subtracting 66. So those are going to cancel each other off there. So let's see, I get 21y minus 15y. That's going to be 6y. On this other side, we have 61 minus 66. Check me there. That's a negative 5. And then we're going to divide both sides by 6. So we get y equals negative 5/6. So again, ugly fraction problem to begin with. We got rid of the fractions. We kind of did all the intermediate steps without using any fractions. And then lo and behold, the answer to the problem turns out to be a fraction, but that's totally okay. Now, let's take a look at this one. We've got some decimals to deal with here. So I'm going to slide this down. Got to grab the calculator, get it fired up and doing this problem. So we're going to distribute through here. So this is going to be, let's see, negative 3.2 times 2. So, whoops, I did a plus. Again, notice we always want to double check and make sure we got that part right. I'm just going to go ahead and recall that, change that to a multiplication. Negative 6.4, which is what we'd expect. So again, negative times a positive is negative. 3 times 2 is about 6. And if we have the 0.2 in there, so that'd be negative 6.4. So negative 6.4n. We've got negative 3.2 times, hit the right one there, 2.1. Notice that this is a little bit bigger than that, so we should get a negative, but the negative should be a little bigger than 6.4, and it is negative 6.72, so negative 6.72. And then over on the other side, nothing to simplify here, so we've got 8.8n minus 2.56. Now we can go ahead and start solving this. I'm going to move the smallest one, that's this negative 8.8, so we're going to add 8.8n to this side. I'll go ahead and cross it off right here, which means we're going to move this guy, so we're going to be adding 6.72. So let's see what we've got here. We've got negative 6.4 plus 8.8. We expect a positive answer out of this one right here, and we do. We get 2.4n on this side. And then on the other side, we've got negative 2.56, and we're going to add 6.72. Again, make sure that we've got this typed in the right way. Hit enter. And 4.16. So 4.16. Notice that we've got a positive coefficient right here, which is what will happen when we move the smallest one every time. And it just so happens that the other side is also positive, so that we're much less likely to make mistakes in this case. So we're going to divide both sides by 2.4 and see what this spits out right here. Again, kind of a pain here. You have to use a calculator. Oh, let me do this. 4.16, I'm just going to hit divide. Whoops, I guess that won't work. I can recall that answer by just hitting A and S, so I'm going to hit second and negative. There's the answer, and we're going to divide that by 2.4. Let's see what we get here. 1.7333 repeated. So 2 decimal places, there's the hundredths place. Look one past that. That 3 is not enough to bump it up, so we're going to call this 1.73. And again, that's approximate answer. That's not perfect, but we were told to round to 2 decimal places, so we're in good shape there. All right, now let's take a look at F and F here. These both, this one has a double star, so it corresponds to this box right here. And this one is very similar. You'll notice what's going on here. So take a look here. We've got 2.9x plus 4 and then 5.6x minus 2.7x. So this side is not simplified here. So we need to do 5.6x minus 2.7x. So I'm going to do, let's see, clear that off, 5.6 minus 2.7. And we end up with, let's see, did I type that in the right way? I did. So here's what we get, 2.9x plus 4 on this side and 2.9x on that side. So here's what I'm going to do. Since there's only one constant in the problem, I'm going to move this 2.9 over there, and I'm going to do that by subtracting 2.9x here. Those are going to cancel. I'm going to subtract 2.9x here. So what I end up with on this side is a 4, because those are additive inverses. They turn into a 0. And over here I have 2.9x minus 2.9x. Well, 2.9x minus 2.9x is 0. So on this side we end up with a 0. So do you remember these special cases? What numbers would make these equations true? So we want a number that we could plug in here that would make sure that 4 is equal to 0. Well, this is never true. There's no way 4 is ever going to equal 0. So you might recall that what we get here is no solution. There is no number that makes this equation true. So I'm going to go ahead and circle that. and I'm going to write no number makes this equation, oops, I'll just abbreviate that, true. There's not a single one on the planet that would make that equation true. Now, you don't have to write this. I'm just writing that for just kind of the benefit of clarity. Just write no solution. That would be totally okay. Now, I'm going to slide this down, and this is related to that other one. That's why it's got an extra asterisk on it. So we've got 2.9 x plus 4 equals 2.9x plus 4. Well, stop and think about that. What number would make that true? Well, this says 2.9x plus 4 equals 2.9x plus 4. Well, that's like no duh. Now watch what happens if we actually go through and solve this, and you might already know what the answer is. They're both simplified, so we're going to subtract 2.9x from each side because I want to get the x's on one side. And what happens is the variable goes away completely, just like it did up here. Here it went away completely, and the two numbers that were left did not equal each other, so there was no solution. Here we end up with 4 equals 4. So if these two numbers equal each other, just like this side equaled that side, there's no way to mess this up. Any number you want to plug in here would make this true. So what we say is there are infinitely, there's an E there, infinitely many solutions. Infinitely many solutions. So that is the answer. We'll go ahead and circle that. Whoops, gotta bring that back. There we go. Any number will make this equation true. We'll make this equation true. Anything you plug in there would make that true. Okay, so I'm going to bring this back to full screen here. We'll take a quick look at this. So we've solved a whole bunch of multi-step equations, used some of our cool inverse operations, cleared some fractions and everything. And what you need to do now is you need to rate yourself on how well you understand these multi-step equations on a 1 through 4 scale. Go ahead and work on the assignment. You'll have a rating at the end of that. And then let's get ready for the test on this. Really got to be good at solving equations. Good luck with the assignment.